Our next lesson is called Using the Graphing Calculator to Graph in Slope-Intercept Form. So the goal today is to continue to review slope-intercept form y equals mx plus b, practice again how to change an equation into that form, but a large part of today is learning how to use the graphing calculator to help you graph in slope-intercept form. So we're going to start with part 1. It says, in order to use the graphing calculator for linear functions or linear equations, the equation must be in slope-intercept form. That's super important. So I'm going to highlight that. The equation must be in slope-intercept form. M is the slope and B is the y-intercept. So you can remember that from our previous lesson. So for our first examples, we're going to put the following equations in slope-intercept form, which remember means you want to solve for y. So I'll complete the first one with you, letter A. We want the equation in y equals mx plus b form, which means we need the y to be alone. Looking at the equation in letter A, we have negative 3x on the same side as the y that we do not want to be there. So we are going to undo subtraction by adding. I'm going to add 3x to the left. Whatever I do to one side, I must do to the other. So that will eliminate my x's here, and I'll get y equals 3x plus 1. Now, remember, I could also write 1 plus 3x, but I tend to pick 3x plus 1 because then it's in literal mx plus b order. Either way, you should be able to identify the slope by looking in front of the x and the y-intercept by looking at the number at the end. At this time, I'd like you to pause the video and you are going to finish trying examples B through F on your own. When you're ready to check your answers, you can resume the video. Okay, at this time, you've tried examples B through F, so now let's go through your answers. So in part B, you should have subtracted 5 both sides for an equation of y equals 3x minus 5. In part C, it was a two-step process. You had to get rid of 6x by subtracting 6x from both sides, then dividing every single piece by 2. So you can see I had to do that in 3 different places. So you get y equals negative 3x plus 2. In part D, we got rid of x by subtracting x from both sides for an equation of y equals negative x plus 25. In part E, you had to subtract 5 from both sides to get y equals 1/2 x minus 5. And for the last one in part F, you subtract 0.4x from both sides. You then have the second step of dividing everything by negative 0.5. So your answer is y equals 0.8x minus 20, which in some instances would be fine to leave it like that. If you were going to graph this by hand, however, and you wanted to utilize the slope and use rise over run to actually find points, it would be easier for you to convert 0.8 into its equivalent fraction, which in this case would be 4/5, so that you could then understand you're plotting your first point at negative 20 as a y-intercept, and then you would be going up 4 into the right 5. So sometimes switching from that decimal to a fraction might be something that you want to do. So now moving on to part 2, we're going to talk about basic graphing using your graphing calculator. So first of all equations are entered into the calculator using your y equals button, which is on the top left side. If we look over here at the right, couple important things to point out. Across the top here are plots that are used in later chapters. You want to make sure that none of your plots are turned on. So if the plot is turned on, it will be darkened. As long as there's not a dark background behind it, those plots are turned off. Similarly, if you look at these two equal signs, notice that the one equation has a darkened equal sign. That means when we actually were to graph it on the graphing calculator, it would show up. Because y2 does not have the equal sign darkened, that equation would not show up. So it's important if you want it to show up on your graphing calculator that you make sure that it's dark behind it. Now for all of these, to turn them on and off, you just use your arrow keys to go up to this wherever you're referring to, either up to the plot or to the equal sign, and enter turns it on and off. Now let's look at the typing options that we see here. The example they're using is the equation y equals negative 1/2 x plus 3. So there are a couple different ways, actually 3 different ways that you can type it into your graphing calculator. If it's a nice decimal, meaning the fraction changes into a nice rational number that is a terminating decimal, You could convert it and type it in as that. So that's what the first line is doing, negative 0.5x. The second option would be to use the fraction key, which we have talked about in class, but I will be demonstrating for you shortly. And then in the third line, if you want to use division, you have to make sure you use parentheses around the two numbers that you are dividing in order to make it your fraction. Now looking down here below at this next section here, this is a picture of an older graphing calculator. So all the things that you see to the left of the Y1, Y2, Y3, etc. are ways you can change what the line looks like. If you have a color addition calculator or using the school color addition calculator, these appear as different colors. Either way, you go to the left of those Y1, Y2, etc. using your arrows, and you hit enter to change what they look like. So if you have an older version, you can switch between a bolder line, a dotted line, and a regular line. And again, on the color edition, you can change to different colors if you're graphing more than one line on the grid. Now looking at your graphing calculator, let me point out some of the things we just discussed under number 1. The Y equals button you can see is in the top left corner. Okay, I have already entered the equations from that in the screen here. Just want to remind you that your keypad moves you around up and down, and I will go down to Y4 just to show you again how to enter a fraction. Alpha Y equals is the button you want to hit so that now you can pick fraction, which will turn that into a fraction. Okay, when we're discussing the area to the left, you see I can go over with the arrow and highlight that and change the color if I'd like. Those of you with the older calculator can hit enter and change the type of line. Up here on the top, you can see the plots. Mine are all turned off because they're blue. On my screen, again, yours will be darkened. If I were to have one on, you can see what it would look like. Mine turns red, and I would not be allowed to graph. So you want to make sure that your plots are always off. Now moving on to section 2, the viewing window. Choose the viewing window. We have talked about this before. I would like you to be choosing zoom, which is a key underneath your screen, one of the graphing buttons, and I want you to choose choice 6, which is standard. This will take you to your standard window that you see over here, going from negative 10 to 10 on the x-axis and the y-axis, with an x scale of 1 and a y scale of 1. Then from there, you can manipulate your window, you can zoom in or zoom out. Looking at what number 2 looks like on the graphing calculator, if I wanted to graph these, now remember they're all the same line, because I showed you every single way you could enter it. I want to hit the zoom key and then pick choice 6 by either using my keypad to go down to that or just typing 6. And you will see that your graph will come up in the standard window. If we actually want to look at the window settings, you hit the window key and you can see the negative 10 to 10, etc. there. You're allowed to change your X, min, and max. You can also change your scale at any time if you have a problem you're working on that you need to see more of the picture. But this is a good starting point. Okay, now for number 3. Anytime you get away from the picture of the graph, you can always hit the graph key again to see your graphs. So again, when you originally graph it, I want you to hit zoom 6 standard, but then as you're moving around doing other things on your calculator and you just want to refer back to your graph, you can use the graph button. Number 4 says you can find the roots of the equation if you'd like to. There's a calculate function. I will be talking more to you about this as we get closer to needing things like roots and intersections. Then if you look at number 5, if you need to see the values relating to the graph, you can go to the table. You can control what you see in the table by going to table set, which is second window. So you're going to notice in these notes, there are directions in the left side, and then there are pictures of what you should be seeing on the right side. So if I'm looking at this graphing calculator, again, I can hit graph to go back to a picture of my graph. But if you'd like to see the table, you are going to hit second graph, and that will take you to what the table values are. This is where you will go to write down your work. So now when you are graphing, you will graph it, look at the table, and give me a snapshot of the table as your work. Now this table you can manipulate to show you what you want. You do that by hitting second window. this is your table set screen. So you can decide where you want to start. So let's say I want to start at -5. You can decide what you want the table to change by. Right now I'm going by ones, but you could make this 0.5, 0.2, by twos. You can change that at any point. So that way, when you go back and look at the table by hitting second graph, you can see my table starting at -5. So you can manipulate what you see. Okay, now I would like you to practice. You're going to draw the graph of the equation below and show your work. Please use your graphing calculator to do this. So you might have to change the equation into the proper form and then practice going to your graphing calculator, graphing this, and getting a table of values as your work. When you are ready, you can resume the video to check your answer. Okay, so first you would have had to move 5 because we want it in y equals mx plus b form. So it's y equals 3x minus 5. Then, when I type that into my graphing calculator, graph it, and take a look at the table, I'm going to give a snapshot of the table as my work. So -1, -8, 0, -5, 1, -2, 2, 1, 3, 4. I also had 4 and 7. 5 points should be plenty. I did 6. So -1, -8, I'm going to plot 0, -5, 1, -2, 2, 1, 3, 4, and then 4, 7. You can see it's following in the pattern of a line. Going to connect it, put arrows on the ends, and then make sure you label it with the original equation, y plus 5 equals 3x. It is going to be difficult to read these points off of your graphing calculator, so you are going to need to rely on that table to help you identify the specific points, which will make it easier for you to graph. And that concludes your lesson on using the graphing calculator to graph in slope-intercept form.